Hi everyone, in this video we are going to graph tangent and cotangent. So remember last week we talked a little bit about what happens with these graphs when we made that big chart and graphed those points. So tangent and cotangent are way different than sine and cosine and what their graphs looks like. Remember there's undefined values of tangent and cotangent, so that means we're going to have those asymptotes. Okay, so let's first start talking about what the basic graphs have. So do you remember when we did those graphs last week what the period of tangent and cotangent was? Good. So it was just pi. So that means the formula to find our period would just be pi over b. So it's not 2 pi over b like it was for sine and cosine. Tangent and cotangent are different. So let's take a look at our basic graphs inside, and then we'll go back and do that example in the front. So we had different values. So remember, if we plug in pi over 2 or negative pi over 2 into the tangent function, we get that undefined value. So that's where our asymptotes come in at, is those undefined values. And then if we plug in negative pi over 4, we get negative 1, 0, 0, and pi over 4 is 1. So we know our period of plane tangent is pi. So let's start by making our asymptotes at negative pi over 2 and pi over 2. And then we can graph our points. So we have at negative pi over 4, we're at negative 1. 0, we're at 0. And 1, we're at, or pi over 2, we're at, pi over 4, we're at 1. So if we connect those, our graph would look something like this. So remember, we go up and approach our asymptotes, but we don't actually cross them. So when we list our domain here, we're just going to list what the cycle is for one period of our domain, because it's going to repeat, and then we would have to, it goes forever, but with excluding those pi over 2's and every pi after that. So we could write that as an equation, but we're just going to, for now, write it in as what that one cycle is. So this one piece of tangent graph will go from negative pi over 2 to pi over 2, but it's parentheses since it's not including those values. So think about the range going up or down to up. What are we going to hit with that graph? Well, we could hit everything, so negative infinity to infinity, since it keeps going up and down. So that's our normal graph for tangent. So when we graph translations of that tangent graph, it's going to be a little bit different than graphing sine and cosine because we don't start at 0. So our period affects the outside part, so we have to do it a little bit differently, which you'll see in a second when we do our first example. So let's do all the basic stuff for cotangent, and then we'll work on our examples. So we know that at 0 and pi, cotangent's undefined. At pi over 4, we would get 1. At pi over 2, we get 0. And then at 3 pi over 4, we get negative 1. So for cotangent, our asymptotes are in different places, but we still have those asymptotes. So we're at 0 and we're at pi. At pi over 4, we're at, this graph is wider than the other one is, so it's going to make it look way different than tangent, but it's not really that different. It looks more stretched out, but that's because our graph is covering a bigger, it's stretched out more. Okay, so if we connect those points in the same kind of curve that we did for tangent, we would have something like this.
7th and 8th grade language arts teachers, please stop by the first floor of the 6th grade building this morning to pick up some books Ms. Thompson has been able to procure for us. Again, 7th and 8th grade language arts teachers, please stop by.
This announcement's never going to be over.
Room,
okay, so we have our period of pi, our domain is from 0 to pi, and our range is just like the other one from negative infinity to infinity. So if we take a look at the two tangent and cotangent graphs, obviously where their x values are is different because this one starts at 0 and that one starts at negative pi over 2. But if you look at their y values, they are just opposite, and that's because they're inverse functions. So tangent always, unless it has a different kind of translation, like the amplitude's negative, it's always going to go up, whereas cotangent goes down. So that's a helpful way to remember which one is 1, 0, negative 1, and which one is negative 1, 0, 1. Tangent's going to go up, so it starts at negative and then goes positive, or cotangent goes down, so it starts positive and then goes down to negative. Okay, so let's go back to the front and look at this example that we have. So we're going to, let's list out everything we have and see what we got from there. So our amplitude for this one is negative 3. So that is going to stretch our graph up and down. But since it's negative, it's also going to flip our graph, like what I just talked about. So it's actually going to look like a cotangent graph instead of a tangent graph because of that negative. Our b is 1/2. Our c is 2. And there's nothing being subtracted with this x or added, so our shift is 0. So our b is our horizontal stretch, our c is our vertical shift, and our d is our horizontal shift. So we have no horizontal shift. So remember that your period for tangent is pi over b. So we would have pi over 1/2, which gives us 2 pi. So that means instead of completing a cycle in pi, we're doubling it. So it's going to be stretched out a lot horizontally. So our interval would be 2 pi over 4, which is pi over 2. Okay, so we'll make our table. So whenever I start, I always put the undefined at the end because we know that that's not going to change. So remember how I said that tangent we're going to have to do a little bit differently? And that's because of tangent not starting at 0. So our tangent actually starts at negative pi over 2 to pi over 2. Since we have no horizontal shift, we know that the center of our graph is still going to be at 0. But since our period's different, that changes what our n values are. They're not going to be negative pi over 2 and pi over 2. So what I usually do is I make an inequality and solve that for x, and that tells us our n values. So I set it up with the normal values of the n's points for tangent. So normally we go from negative pi over 2 to pi over 2. And then I stick whatever is with my x. Usually, you'd have like the shift with it. And I take that whole thing and I put it in the middle. When I solve this for x, that's going to be our n values, where we're starting at. So for this one, it's not that hard because we don't have the horizontal shift. So we would just multiply by 2 to get x by itself. So that means our n values are going from negative pi to pi. And I hope that makes a lot of sense. Since we're doubling our domain, we're doubling those n values. So between here is still 2 pi, which is what our period is. Normally between here is pi, which is our normal period. But writing this and solving the inequality really helps when we have our shifts. Okay, so take those values and we'll put them at the ends of our graph. And then we know, well, we could do our interval. You know it's between negative pi and 0. That'd be negative pi over 2. Or remember, if we add pi over 2, add pi over 2, add pi over 2, add pi over 2, we would get that. Good. So next we'll do our y values. And I drew my table so low, I'm just going to write them out here. So, like I said, since I always just put the undefined right there, we really are only dealing with those 3 middle y values. So for tangent, it's negative 1, 0, 1. So apply your amplitude. So we're going to times by negative 3. And then add or subtract your shifts. So in this case, we're adding. So we have 5, 2, and negative 1. Okay, so just like for the other ones, I already pre-made my graph. So I know my asymptotes are at negative pi and pi. So now really all we have to do is graph those middle points. Okay, so at 5, or I'm sorry, at negative pi over 2, we're at 5. 2, 4, 5. At 0, we're at 2. And at pi over 2, we're at negative 1. So remember I said this graph is going to look like cotangent because of that, that negative amplitude. So that's why it's starting up and going down instead of starting down and going up, because that negative flipped it the opposite way. Okay, so let's take a look at our next graph. So we got another tangent. This time we do have a shift, so we'll be able to see what happens when we have that. So we're going to start out by finding our period. So our period equals pi over b. So we have another one that is 2 pi again. And then our interval, again, will be pi over 2, just like the last one. Okay, but this time it's different because we have that shift. So we're going to write our inequality, normal endpoints. And then in the middle, I'm going to put this whole thing, instead of just the 1/2 x, we're putting that translation in it as well. Okay, so 1/2 times x plus pi. And when we solve this for x, we're going to get what our ends are, where our asymptotes go. So times by 2 to get rid of the fraction, just like we did on the front. So we'd have negative pi, x plus pi is less than pi. So to solve for x, we would subtract that pi. So our left asymptote will be at negative 2 pi, and our right asymptote will be at 0. So from here, we'll make our table. So these are our starting and finishing points. So we have negative 2 pi and 0. And those are our asymptotes, so they're undefined. And then if we add pi over 2, we'll get all of our values in between. So this is like negative 4 pi over 2. So negative 3 pi over 2. Negative 2 pi over 2. And negative pi over 2. So our normal y values for tangents are negative 1, 0, and 1. So apply your amplitude, and then apply your shift. And those are going to be the numbers that we use to graph, with our endpoints being our asymptotes. Okay, so for my graph, I made each box be what our interval is, so pi over 2. So first we'll graph our asymptotes. So we have an asymptote at 0. Then we have an asymptote at negative 4 pi over 2, or negative 2 pi. I know it doesn't look like it's stretched out that wide compared to this graph up here, but that's because the boxes are worth a different amount, so it's not like stretching it the same. If we wanted to actually see like the shifts and stuff, we would have to always make the boxes worth the same amount instead of what our interval is like equal to. But to graph, it's just easier to make each box your interval. Okay, so if we graph our points, we have 0, 2, and 4. So this is what, remember, a normal tangent started down and went up. So since we didn't flip, this is what tangent should look like. Okay, very good. So let's take a look at our last graph. Since cotangent starts at 0, you don't have to do that inequality thing. And I know you probably didn't like that. So you don't have to, because the shift is going to be Like this is going to put it where it would be since we're shifting from 0 and not shifting from negative pi over 2. But you can do it. I mean, you really technically can do it for any of the graphs, and you would get the same thing, or it would work out the way it should. So just keep that in mind. Usually I teach doing cotangent just like doing tangent, because then like you won't forget when you have to do it or not. But you don't have to. It could be done just like sine and cosine. So if we think of it as like what we would do for sine and cosine, our first value would be what our shift is. So we would start at negative pi. Okay. So let's do the inequality together so you can see that that's what you're going to get from the inequality, and then you can try the rest by yourself. So the way we would set up inequality is we put all of this stuff in the middle, and then our endpoints are what our normal endpoints are. So for cotangent, that's from 0 to pi. When we did tangent, we did negative pi over 2 to pi over 2 because that's the normal end values for tangent. Okay, so it depends on what each graph's normal graph looks like. So if we solve this for x, we would have that it's, oops, I forgot to subtract my pi. So subtract pi from all things, so we would have negative pi x negative pi over 2. Okay, so you still get the same thing that you would do if you use like the sine rules that we did from graphing sine and cosine. So from here, I would find your period, your interval, to find all those numbers in between, and then find your y values. Okay, so go ahead and try to graph that, and when you come back, I will show you what our graph looks like. Okay, so we got negative pi to pi over 2. Our y values ended up being negative 1, negative 3, and negative 5. Okay, because cotangent goes down. So I graphed a bunch of the periods here. So from negative pi, that would be here to JK, negative pi would be from here to here. Okay, so that's the cycle, the normal cycle, that one for this graph. That's where it first starts. And I did 2 more just to show you what could happen to it if you keep going. And then we're going to see that same thing repeat over and over and over and over again. So we could go even this way. But this one in the middle, that was the one that you would have gotten if you just graphed one cycle or one period. Okay, make sure you write down any questions, and we'll practice doing this inequality thing in class tomorrow.